Isabel, the Fair Image Data Steward of Euro-BioImaging, and in this section, we will start with the basics of the FAIR principles within the domain of bioimaging. So according to the 2021 NFDI for Bioimage survey on data management, a survey that I will be mentioning quite a bit during my sessions, only about 25% said that the FAIR principles are clear to them. And I hope that by the end of this workshop, we will have increased that number, at least within this audience. And at least since reading the announcement for this workshop, you will know that FAIR stands for findable, accessible, interoperable, and reusable. And at the core, FAIR defines a set of principles and guidelines so that data can be shared in a way to enable and promote their reuse by both humans and machines. Maybe you know from first-hand experience, or you can probably imagine that producing data according to the FAIR principles requires time and effort. So we will first look at the benefits for the scientific community. Why should we even care? And why have these principles been developed in the first place? So first of all, recording data according to the FAIR principles improves the transparency and reproducibility of the research, which then in turn enhances the quality and the robustness of the underlying data and thereby the results. And these 2 points in combination now increase the overall value of each data set. Additionally, by having good quality data in a shareable format, we increase the collaboration within the community. All of this together leads to accelerated method development or even the development of new research fields, and thereby increases the scientific progress as a whole. So I would say these are all very desirable outcomes. And we also see these benefits in other life science communities that have already successfully implemented workflows and principles that resemble those of FAIR, even sometimes long before the official statement of the FAIR principles in 2016. Like, for example, in the domain of structural biology, I think nobody would doubt that a protein structure that is generated is deposited in the PDB for everyone to use, and in the PDB that these data sets are associated with quality measures. On the other hand, for biological images, we are just right now witnessing this shift to the realization that our data can be much more valuable if we try and go the route of making them fair. But as already mentioned in the previous talk, there are certain challenges for bioimaging that limit an easy and straightforward implementation of the FAIR principles. Let's take, for example, the size of data, where nowadays experiments can easily reach terabytes of data. And if we want to share all the raw and analyzed data, we have to think about ways to deal with that amount of data. And secondly, bioimaging is very diverse in terms of imaging methods, and those often then produce complex and sometimes multimodal data sets. So we can't really have a one-size-fits-all approach. On top of that, microscopy data often gets recorded with non-widely adopted standards and often in various and even proprietary file formats. So at this point, we have to think about how to deal with that heterogeneity of bioimaging data. And all of this might sound a bit discouraging and like we can't really get anywhere in the near future. But I want you to remember from this is that FAIR is not a binary outcome. It's not either you're completely fair or not at all, but it's rather a spectrum. So it's always worth to start somewhere, and especially if many people do small steps in the right direction, we can together move the field of bioimaging towards more fairness. Here I've now visualized the FAIR spectrum along 2 dimensions, those of FAIR enthusiasm and FAIR knowledge and practice. And of course, the goal is to move towards the target zone in the upper right corner. And now I would like for you to rate yourself along those 2 directions, to ask yourself how knowledgeable and how enthusiastic am I about FAIR? And maybe you're already doing FAIR because somebody told you that you had to do it, but you don't really see the benefits. then you would be here in the bottom right corner. Or maybe you really like the concept, but don't know where to start, then you would be here in the upper left corner. And I would also like to point out that people in each of the quadrants need different things in order to progress towards the target zone. For example, in the bottom left, where the person is not really enthusiastic and also not really knowledgeable, they would benefit from success stories. While on the bottom right, where they are quite knowledgeable in fair practices but not quite enthusiastic, they would benefit from easy workflows to make their life easier. In contrast, on the upper left, where the person is already quite enthusiastic but doesn't know where to start, they would highly benefit from actionable steps. And even for people in the upper right corner, which are already quite enthusiastic and knowledgeable about FAIR, they would need recognition for the work that they are already doing, so they would not be tempted to go down the spectrum again. This workshop now will hopefully contain something for everyone, independent of where you are on the spectrum. And now we will first start with some easy and actionable steps towards fair bioimage data. And you will see this slide reappearing several times during the presentation, and it is split into things that an individual scientist can do, as well as, on the other hand, what facilities can do to increase the fairness of their user projects. And of course, this is not a list to get you to 100% fairness. If that's at all possible is another question. But it's just simple steps to get you started and in motion so that together we can make small steps and make bioimaging more fair. And the first thing on the scientist side would be to inform and assess yourself, which you're already doing by attending this workshop. And you can ask yourself in your daily work which aspects of your work are already fair and which could benefit from some improvement. Whereas on the facility side, they can expose their users to the FAIR concepts by maybe hanging up FAIR posters, which we at Euro-BioImaging are and will be producing for everyone to download. So now we will stay on the topic of informing yourself, and we will have a deeper look into what the different aspects of FAIR actually entail according to the original publication. So in order to be findable, data is described by rich metadata and registered in a searchable resource that provides persistent identifiers. In order to be accessible, we use a standard and open communication protocol to retrieve the data and metadata. The metadata is even longer available or shared with a broader audience than the data itself. Data is interoperable when it can be combined with other data and interpreted with other tools, for which we need references with other data and the use of controlled vocabularies. And lastly, data is optimized for reuse if it states a clear license for reuse and is described by accurate and relevant metadata according to community standards. And I know this might have sounded quite technical, therefore I try to reduce the FAIR concepts to a more simple version with the core values. So this means in order to be findable, we should have a persistent identifier associated with the data set. To be accessible, we should define a standard access protocol. To be interoperable, we should use defined vocabularies and file formats. And to be reusable, we should have a reuse license and rich metadata included. All of this might sound as if FAIR data has to be necessarily completely public, because we were talking a lot about data sharing. In fact, FAIR data and open data often get used as synonyms, but they are actually different concepts. So FAIR data, on the one hand, is always managed to some degree, whereas open data does not have to be. The only criterion for open data is that it can be used and shared and built upon by anyone, anywhere, and for every purpose. Whereas for FAIR data, this can be, but doesn't have to be the case. So we can have FAIR data that is only accessible within a closed group with permissions to be requested to respect any legal or ethical restrictions or any other restrictions that you might have. On the other hand, if you just upload an uncurated data to, let's say, a personal homepage, it is per definition open. but it's not fair because it's not findable, reusable, or interoperable. But of course, we aim to have fair data as openly available as possible. And this will have then the biggest impact on the scientific community. But I want you to remember that also if you're dealing with more sensitive data, that your data can and should be still fair, and many things of this workshop will still apply for you. And even if you have non-sensitive data, of course, I understand that putting your data openly available might sound daunting and also a bit scary at the moment. And that's why we will now look into the benefits for the individual scientist. And first of all, even though in the beginning it might take more time and effort to actually make your data fair, having fair data is time-saving in the long run because it reduces the time for data organization, paper writing, and peer review. Additionally, you get more citations on those papers where the data is properly described and available. And this then in turn also increases the visibility and findability of your work, even beyond the paper. On top of that, depositing data in a database provides you with a secure place to house the data set. And also you in the future, when you leave the original institute, can always have access to your own data. And last but not least, fair data is already becoming a criterion for journals and funders. So in the future, fair will no longer be a choice, but a requirement. And that's why it's wise to start now with implementing the FAIR principles. Here I've shown you some examples of current journal requirements, and you can see that they are starting to mandate to follow the FAIR principles, to write a data availability statement, and to make your data available in repositories. But usually they leave you to find out yourself an appropriate repository. And even if they have maybe a list of approved repositories, those for bioimaging are still missing, which then of course puts quite a challenge on the researchers who want to submit a manuscript but don't know where to submit their data. And if you stay tuned for the rest of this workshop, at least for the open bioimaging repositories, you will get quite a good overview of the ones that currently exist. But of course, for other data, this is still a problem. To find appropriate repositories, but also standards and policies, you can use the FAIR Sharing website. And it's a really nice resource that allows you to make connections between resources and display them in sort of this relation graph that I've here shown for the eLife journal and their data policy, where you can see all of the repositories and standards that they require. So as a next FAIR action point on the researcher side would be to check the requirements of the journal that you intend to publish, even way before you prepare the manuscript, if you know where you want to publish, and see if and how you can comply with them already within the data generation. And even if that journal is not requiring a data availability statement, still consider writing one. On the facility side, it would be valuable to advise users to consult with the data steward, if available, as early in the project as possible, so that both the researcher and the data steward together can make sure that the journal recommendations are met appropriately and the processes for that are as easy as possible. And with that, we are on the end of this section of the FAIR Basics, and I hope to see you again in the next section, where we continue the easy steps towards FAIR bioimage data.